Today I finally want to address a topic you guys wanted me to cover for such a long time. And I need to make a confession to you. The reason why this took me so long is that Kubernetes always seemed like a mysterious black box to me. You know, I have used it for quite some time and I've already made some tutorials on deploying workloads and applications on it in the cloud, but setting up a Kubernetes cluster at home is an entirely different thing. I had so many questions that I've gone through: how I'm going to set up the storage, the networking, high availability, and all of this stuff. And because everybody says Kubernetes is so freaking complicated, I was a bit worried about this project. But you know what? In the end, it's all stuff that you can learn. So in this video, we will look at setting up a high available Kubernetes cluster with K3s that you can use in a self-hosted environment like your home network. I will use my Sophos XG firewall and Traefik as a load balancer, and we are using another fantastic open source tool to make sure our Kubernetes deployments work properly in this high available setup, that they don't have any security issues and follow best practice policies. It's called Datree, and it has already become one of my favorite tools for Kubernetes in the last weeks. So you will learn the full package of Kubernetes tools to get started with it in your home lab. I hope you will enjoy it as much as I do. So let's get started. Let's first get an overview of what we're actually doing here and look at the website K3s.io. K3s is made by Rancher and it is a lightweight version of Kubernetes that is made for IoT and edge computing. That makes it perfect for projects where you can put this on a very efficient ARM-based device and use multiple smaller instances to cluster them together. For example, what I've seen is a very popular setup. Take a few Raspberry Pis, they are very small and efficient, and you can run K3s to deploy your containerized workflows in a centralized, high available way with that. It's really amazing. And it probably would be a nice project I might also do in the future, so if you find this video helpful and you like to see more content, then do me a favor, like this video and subscribe to the channel. But for now, I want to follow a slightly different approach because I'm still at a very early phase of testing this, because even though K3s is great on ARM and IoT, technically you can deploy it anywhere. And you can even use it on a virtual machine, physical machines, or any other computing system. It's totally up to you. And it's surprisingly easy to set up. Sure, some high-level understanding of Kubernetes is probably required to get you started, so if that's totally new to you, I've already done some videos about Kubernetes, you can check them out. And by the way, if you're from Germany like me, I also recently started a Twitch channel and a personal YouTube channel in German language. Let's meet there and learn together, that would be really cool. Okay, let's go back to K3s. So for this video, I'm using some virtual machines that I've created on my Proxmox server, and that's where we want to install K3s on. What makes it so powerful is that it's not just very lightweight. K3s is also very versatile and that can be deployed in many different ways. So please don't take my setup as the only way to install it. It's always depending on your use case and what you're planning. On the K3s documentation page, there are some outstanding articles about the architecture and the underlying components of K3s. Please go and read some of this stuff because it's extremely useful. But if you want to go the easy route and just try and test it out on a single node machine, then you should follow this quick start guide that works pretty straightforward. In this setup, you're deploying the K3s server on a single machine, which uses an embedded SQLite database to store the critical data for Kubernetes, and it also runs all Kubernetes management components. But this single node server doesn't really mean that you're limited to run your workloads on this one single server. You can still add multiple agent nodes and dynamically expand the cluster. You can even add a load balancer in this setup and forward the traffic to your applications when they are deployed across these agent nodes. But it's still not a full high available setup because it has a single point of failure, the K3s server node. If that thing goes down, the whole cluster is down, and you can't even run any agents or workloads. And I don't want to say this is necessarily a bad thing. So if you're running a home lab, you always will have many components that are not redundant, and you always will have points of failure. So this isn't a terrible idea, but I still think high availability can make sense even in a home lab. So just imagine you want to run some maintenance work on the server node, like running updates, or something goes wrong and you need to restore it from a backup and so on. So that's why I wanted to run the K3s server on more than one node. And here you have also different options how you can achieve that. So the first one is to install the K3s server on multiple machines connected to an external database, which can be a separate server where you're running something like MySQL or Postgres. This requires 2 or more server nodes and is perfect for a dual server setup, so to speak, but you can also dynamically expand this cluster and even add more servers or more agents to it. And if one of the K3s servers that you have goes down, you always will have a second or third server as a backup that can still connect to the external database, and the Kubernetes cluster will still operate functional. That's why it's called high availability. It also requires you to have a registered address, so this is just another word for saying it needs a load balancer that receives all traffic that should come to the cluster and then forwards it to the actual K3s servers. Sounds like a great idea, but this setup has also a small drawback. Because the external database that you need, this can also be another single point of failure. Because if the database server goes down, it doesn't matter how many servers you have, they just can't operate. And there are of course solutions for this problem, like running a MySQL cluster with a database replication, but when you really think about it, this is a point where it already starts getting too crazy for me in a home lab. So there is another setup that I personally think is probably the better option to deploy it. And that is to run like a mixture of both things, because we want to have high availability on our K3s server setup, but with an embedded database, not an external one. And this is also possible now in one of the latest versions of K3s, because they introduced an embedded database solution with etcd. If you know Kubernetes a little, you know that etcd is often used as a preferred database for Kubernetes. And that is, by the way, pretty interesting to know, because etcd is used in Kubernetes for a reason. I've done some researching on this topic and I found a pretty great article which explains the characteristics of etcd and how it relates to Kubernetes in comparison with a relational database like MySQL or Postgres. I will link this article in the description down below, but just to summarize it, relational databases are heavy and they are made to store big data, run stored procedures, have foreign keys and relations between tables. This is something that is not needed in Kubernetes. A Kubernetes database is very small in size, but it is a big key value store, which should be also deployed in a high available scenario, which is also dynamically scalable. So we have completely different use cases here when we want to deploy a database for Kubernetes. And here relational databases also have their limitations. It's even hard to build a replication between 2 MySQL servers. Just imagine you want to do that with 3 or more. And this is something that etcd is specifically built for, so you can very easily add many different nodes in an etcd database cluster and make it also high available. I won't go over this whole article because it's really long. It's still interesting to read, by the way, but the main important part for us is the fault tolerance of etcd. And this requires at least more than half of the instances to be online. So if we look at the table, you can see we need at least 3 nodes to achieve fault tolerance in etcd. So we need 2 to operate functional. Now, if we want to add another node here and we have 4 etcd instances, we can still lose only 1, because when we would lose 2, that wouldn't be more than half. So adding another K3s server to a 3-node cluster to make it 4 nodes, that doesn't give you any more fault tolerance. However, if you now start adding another node that we have 5 nodes, we can compensate the loss of 2 nodes. So the conclusion is the more nodes you have, the more fault tolerance you add to the cluster. This is so interesting, and after reading this, it now surprisingly starts making sense that everyone recommends at least 3 nodes in a Kubernetes cluster. I always ask myself, why is this the case? And now I have created another diagram how I want to set up this Kubernetes cluster, and don't worry, we will get to it in a minute, but I think this is really important to understand before diving into creating this cluster. So in my setup, I'm running the Kubernetes cluster on 3 virtual Ubuntu servers that I'm running on my Proxmox machine. They all have a separate IP address, 10.20.4.1, 2 and 3, and I will install the K3s servers on all of them, and they will run the full package, an etcd database instance, the control plane, act as a master, and also run all the workloads. The traffic for any users or external sources is routed to my Sophos XG firewall, which will act as a load balancer and forwards the traffic to all the 3 nodes. In the Sophos XG, you can use a simple NAT rule with a load balancing feature. I will show you that in a second. But of course, you can also use any other firewall system that's capable of load balancing. But in my case, That firewall is already the central point of where traffic is going through in my setup, so using it for load balancing just seemed like a good idea. To use the Sophos XG as a registered address for K3s, we just need to create another IP address for it, and we also can create a DNS name that points to this address. In Sophos XG, that is relatively simple. You can create alias IP addresses on any incoming interface, and here this registered address will be the IP address 10.20.2.2 with the DNS name kubedemo1.clcreative.home. So that is my setup. I know it realistically still isn't a real high available setup because it's still running on a single Proxmox server, so when this thing bursts into flames, I'm screwed anyway. But this demonstrates well how it could be made high available when running 3 or more nodes with Kubernetes and the embedded etcd, and when this would be used on separate physical machines which are not dependent on a single entity like a MySQL database. I think this is a pretty great setup. Okay, so I guess the introduction again took like half of the video. I know you want to get started, so let's do this and install the K3s server nodes. So on the K3s documentation, you can find some detailed instructions about K3s, and it's really good. However, the part that I think is a bit confusing here are the installation options, because you can install K3s with a script or from binaries, and sometimes the documentation just mentions the script installation, sometimes in another section they just mention the binary installation, and that was a bit weird. So I've wrote my own documentation about the different deployments that I have tested, and I've tried to use my preferred method of installing K3s with a simple bash command that you can just copy and paste into the shell. On my GitHub profile, just open the cheat sheets repository, so this is my personal IT documentation about all the projects that I'm doing, and then navigate to Infrastructure, Kubernetes. And here you will find a lot of helpful information about Kubernetes and K3s. Let's go into the K3s install HA embedded DB document, so here we can just use the command templates to install the first server. For this demo project, I've created 3 demo servers on my Proxmox machine. These are virtual Ubuntu instances in the latest version 20.04 LTS, but you can in theory just install K3s on any other Linux distro. You don't need to prepare much on the server itself to execute it, because the script will do all the setup and installation for you. The main important thing is that you need to replace some of these parameters with your own settings. And the first parameter that we need to change is the token, because we need a shared secret that we use on all these 3 servers as an authentication between them. So I've just put a generated new secret and put this into the command. And next we also have the TLS SAN. So this is something I quickly need to explain. So if you're using a Kubernetes cluster and you want to authenticate to it via kubectl, so you connect to it to add new resources or change settings, it's always using HTTPS, and HTTPS always needs a valid certificate. And this certificate is of course generated by the K3s installation script. However, this certificate just uses the IP address of the first server when you're installing it. But remember, we don't want to use the IP address of the first server to connect to it. We want to use a registered address on the firewall instead to use it as a load balancing. And this has a different IP address and of course a different DNS name. So when K3s now wants to generate a valid self-signed certificate for the registered address, we need to tell it through these variables. Otherwise you will always get a certificate warning in kubectl. So let's just put the IP address 10.20.2.2 and the DNS name kubedemo1.clcreative.home. So this will be the registered address that we use in the XG firewall. And the latest parameter is also very important, so this will tell K3s, hey, please install the K3s server with an embedded etcd database that we need for clustering. So when you execute now this script, it downloads all the necessary packages and the software and initializes the cluster. That doesn't really take long once it is finished, and now in my example the K3s servers was running and ready to work. So I've now opened a shell into the second server and also installed K3s here. I've just used the same command but with a small difference. So we don't want to initialize a new cluster here, of course. Instead, we want to connect to the existing K3s server to join the cluster on the first server. So here we just insert the IP address of this first server and the port of the Kubernetes API that's running on it. That's always support 6443. And that's now installing the second server and joining the cluster. But to achieve fault tolerance, remember we need 3 servers. So let's also open a shell to the third one and let's just copy paste the same command as well. And that's it. Kubernetes is now installed in HA mode with an embedded database. You can also check if the cluster was initialized successfully by taking a look at the journal CTL to get the logs and sysctl to check if the K3s service is running. I've checked that quickly on all of the free servers, and if they work properly, you can also execute the K3s kubectl console command and you should see them there. You can just use sudo K3s kubectl and then get the nodes to check the health of the cluster, and here you should see that all 3 nodes are connected and are ready to work. No, that was Kubernetes, but we also need the load balancing, the registered address, because just like I said, we need one central address where all the incoming traffic is routed through these free servers to the cluster. And we also should have some logic to check if the servers are still online. This is something I could easily do in Sophos XG. By the way, if you're interested in this firewall system, I've also done a separate tutorial video on installing this as a virtual machine in Proxmox. It is completely free in the home edition and very powerful, so just check it out. You will find a link to this in the video description. In the web interface of Sophos XG, we first need to generate another IP address that we can use as a registered address where the traffic is coming through. So that's pretty easy. You just need to go into network where you have all your network interfaces and add an alias. So this is like an additional IP address on a network interface, so we need to select the main physical interface of the network card where your K3s servers are connected to. So usually that would be the internal interface. In my case, that's a trunk port, which is also connected to the DMZ zone where the virtual machines are running. And here I just added the IP address 10.20.2.2 in the DMZ subnet and saved these settings. So now the firewall is reachable on the main IP address 10.20.0.1, but also 10.20.2.2. Also remember this name here, that's the name of the IP address object that we need to use later. We also need to create one object for our free servers. So in the host and services menu of Sophos XG, I've created another IP host with the name kubedemo1. Note that is not a DNS name, just the object name. And here I changed the type from a single IP address to an IP list. So this allows me to add all the free IP addresses of the internal K3s servers. So this object now represents that list of IP addresses. And now we just need to tell the firewall, hey, if traffic comes in on that additional IP address, route it to these free servers. That's possible in the rules and policies where I just added a new NAT rule. Here we just can tell the firewall this logic, so any incoming traffic that goes to my interface, the additional address, will be translated to the kubedemo1 object, which is the IP address list. So in this NAT rule, I also changed the SNAT policy to masquerading. This technically isn't always necessary, but it means that the original IP address from the traffic source is masqueraded with the firewall's IP address. So when one of the K3s servers receives traffic, it will only see the source address of the firewall and send the traffic back to it. So this allows me to see not only the requests to the firewall, but also the answers from these servers, which might be useful in some scenarios. Now we also need to select our load balancing method, and here I've tried out a few different things that now depends on how you want to set it up. In the Sophos XG online help you can see what these different methods mean, so I won't go into too much detail here because in a home lab situation I don't have the problem that the IP packets need to be routed based on priority or load. This is just a very simple method to create something like a failover. So just pick anything that makes sense to you. In my case I think it's useful to just use a round robin, and also remember to enable a health check, because without a health check the firewall wouldn't notice if a server is dead and just still forward traffic to it even if the server is shut down or K3s is not running. So always select the health check and change the probe method from ICMP to TCP port 6443. I've decided to do the health check on the TCP port of the Kubernetes API because it could be that the server itself might be still online, so it would respond to ICMP packets, but the K3s application is somehow down or it's dead. In this situation the health check would just say, hey, server is online, everything is great, but it's not. So that's why I changed it to check the Kubernetes API port so that the firewall notices, okay, when health check isn't possible, I won't forward any traffic to this server anymore. Whoa, I just realized the networking part is actually much more complicated than the Kubernetes part, but I think we got it now. So that's all to configure the network part here in my setup. Just know that networking can be very complicated, especially when you're doing things like failovers, load balancing and so on. So when this is something you don't feel quite comfortable, you know, This is probably something you need to do some researching and testing. Okay, so we got our Kubernetes cluster running, we have configured a registered address for load balancing. Let's now test it and configure kubectl on my machine. To connect to the Kubernetes cluster by using kubectl, you just need to copy the kubeconfig file from one of the K3s servers, which are located in this directory. I've just copied everything in this file here, and then you need to import it in your kubectl config on your machine. So I've just pasted the content of the kubeconfig file into another one and saved it in my config folder. And now it's really important that you need to first customize the IP address of this config file, of course, and change the local IP address to your registered address of the load balancer or the firewall or the DNS name, whatever you want to use. You should also change the name default to something else, so I've also used the name that I've picked for the DNS record, and this is kubedemo1, so that I can identify this Kubernetes cluster. Now you can switch the kubeconfig context to this new cluster, and that's it. When we now execute the kubectl get nodes, you should see all the free Kubernetes nodes. You can see they are online, they are ready. That's perfect. Now let's start running a simple application on this cluster to demonstrate how it works and how this Kubernetes cluster will react when a server is offline and how to make it high available. By the way, if you're working with Kubernetes a lot on a daily basis and deploy manifests, I want to show you a really nice tool which is called Datree. And by the way, thanks Datree for sponsoring this video. Datree is a free and open source tool to check your Kubernetes deployments to avoid any misconfigurations or security issues in your workflows. It can be perfectly integrated in CI/CD workflows, but what I personally use it for is checking my Kubernetes manifests to learn more about it and just follow best practices. And of course, avoid making stupid mistakes. You can simply download this tool, you can install it on Linux, macOS or Windows and test your Kubernetes manifest files with it before you apply them to the cluster. Just to let you know, this tool can of course do much more, and we might even dive a bit deeper into this tool if that's something you're interested in. You can even create custom policies to fine-tune specific requirements in your organization or environments and manage them centrally. This is really amazing. I've connected Datree to my GitHub account where I manage policies for my environments such as production and testing, because some rules might work well in a production setup, but in a test environment you probably want this tool to be less restrictive and let a few ugly things just pass the test. And that already teach me some cool stuff about Kubernetes that I didn't know, but it's also very important for high availability and this setup. So let me show you that with an example. Let's now open my project folder in VS Code to deploy a simple Nginx container on this K3s cluster. I'm using this manifest, which will run a deployment of Nginx with 3 replicas. With this setup, we should have some pods scheduled across the servers to test the high availability. You can see there's nothing really special here, it's very simple. And I also added a service object to make this Nginx container available from inside the cluster with the cluster IP. But don't worry, we will cover the external address to this pod in a minute. I still now want to run Datree on it before we apply this to K3s, just to make sure we have not done anything stupid here. So if you have now installed Datree, you can enter the test command on this manifest file, and you can see it gets a lot of warnings here because I've checked it against the default policy, and this includes some resource tests that I've just skipped in the testing one. So let's now change it to run it against my testing policy that should be less restrictive and ignore some of the resource issues. And as you can see, it still failed, but there are a few reasonable things to take a look at. And if we now go into Datree, you can also get a history of all these checks you have ran on the system. It's pretty cool, and in their documentation they also have some great articles and details about these tests and why they failed. So let's look at these rules. The first one is ensure each container image has a pinned tagged version. And this is something I've always done wrong. So I've always used the latest tag in my environments because I thought, well, the latest version should be good. But as you might know, new versions can also break existing configurations, and when I carefully think about it, that's not how I'm doing it on other systems like firewalls, Linux servers and so on. I never enable automatic updates, and I always do my updates manually. Now, I won't go into container tags and updating here in this video, but that might be something to cover in more detail, especially what's the difference between version tags and digests. But for now, let's just pick a specific version of Nginx that I've already tested on another deployment and where I can confirm it's definitely working. The next errors are also kinda interesting and very important for the high availability in our K3s cluster. They are called the liveness and readiness probe. In the Datree documentation, they have some great articles about these best practices and what these errors mean. Let me quickly explain it. When the pod where the Nginx server is running and having some issues, for example, the pod is still online, but the web server itself has a problem. For example, it could be that the web application went into an error and it doesn't answer requests anymore. But this doesn't really result in a shutdown or deadlock event of a container. The container is still running, but the application in it is not functional. How should Kubernetes know that? It would just run the container and assume it's still okay. And this is a big problem when we're using it in an HA environment, because in an HA Kubernetes cluster, we want our services permanently online and we want Kubernetes to do a load balancing and fail over when something goes wrong. So what we need to enable here is a readiness and liveness probe that will do an HTTP web request on the container's web server port. Something like a health check on the application itself, if it's still running and responding. And I will just pick the root directory here because this will always return an HTTP success code, just to test it. In production setups, you might want to configure a specific entry point for a health check of your containers, but this is okay for now. When the web server in the pod is now dead and it's not responding to these health checks, Kubernetes will automatically restart the pod and schedule them across any available server in our cluster until it has 3 available replicas. So that's exactly what we want here. Okay, so now that we fixed the configuration and the deployment, let's do another test with Datree on the testing policy, and you can see it now didn't find any errors. So we can now deploy this manifest with kubectl on our K3s cluster. And that's it. Let's switch into this namespace and query the deployments. We should see it here. And to check if our container and service objects are running, let's also get all the resources. That should be also okay. Okay, so you now might ask, how can we get access to this application in our K3s cluster? Because we just have created a service from the type cluster IP. Just like I said, it's accessible inside K3s, but not from outside. Now, here K3s or Rancher has done something really cool because it automatically deploys Traefik as a load balancer by default. So if you don't know Traefik, this is the first time you hear it, you should definitely check out my 2 videos about Traefik on Docker and Kubernetes. There I have explained it in much more detail. But using Traefik on K3s is actually pretty simple. You don't need to know much about it because, just like I said, K3s has done everything to make sure this service is running on all 3 servers in our cluster by default. So whenever you send any network request to any of these 3 servers, Traefik will make sure that it's routed to the correct pod within the cluster. So in theory, you even could just send all the requests to the first server. Traefik would route them correctly inside the cluster. But when this first server is offline, we would have a problem. So that's exactly why we still need another external load balancer, the registered address of the Surface XG firewall. So don't mix internal load balancers like Traefik with external balancing. You kinda need both. Okay, so let's go now back to our manifest. We need to create an ingress object for Traefik, and here this is a pretty simple manifest of an ingress object that will route all incoming traffic on this DNS name, nginx1.clcreative.home, and that will route the traffic to the service object with the name nginx1 on port 80. And that should be all. No, not quite. We also need to create this DNS name and forward this to the firewall's IP address, because the firewall should first accept this traffic, then forward it to one of these 3 servers, and then Traefik will pick it up and route it to the pod. Let's quickly go into my firewall and create a new DNS host entry for nginx1.clcreative.home, and then route this to the IP address of the firewall's additional interface where the NAT rule is attached to, the 10.20.2.2. And now let's deploy this ingress object. Let's first check it with Datree, of course, if we've not done anything stupid on this ingress manifest, but no, it should be good. Let's apply it. And that should be all. We now should be able to reach our Nginx pod on this DNS address, and yeah, there it is. Awesome, right? So I also now wanted to see what happens when one of the servers goes offline and if we still can reach our application. And let's first find out where the pods are running. You can see that when you enable the write output in the kubectl get pods command. And here you can see it's running one pod of each of the nodes. Now this doesn't necessarily be always the case, so if you're running more than one deployment on Kubernetes, it might be that Kubernetes balances these pods based on the server load and availability. So for example, if server 1 and 2 are busy, it could spawn 3 replicas on server 3. That could be the case, but realistically it usually balances them across the entire cluster. Now let's be evil and just shut down the virtual machine on Proxmox. This would be in the case of a kernel panic on this VM or anything like this. Or maybe we want to update this server and just take it down. Remember to take care that we only take one server offline, not two, because the etc database requires more than half of the servers to be online. That's why knowing how the system is operating under the hood is so important. So I've now shut down the first server in Proxmox, and after a few seconds in the kubectl command, you can see that this server is now set to not ready. So it means it's offline because K3s can't connect to the Kubernetes API. But our website is still there. It's still available. We can just run multiple requests to this website and you can see it's always responding. Because K3s has still other pods running on the remaining nodes, and the Surface XG notices, oh, this server doesn't respond to health checks anymore, I won't send any web requests to it anymore. And if the server is started again, it's booted up and ready, it will be available again in the cluster and the traffic will be forwarded to it. That is really nice. But there is one more thing that you need to take care of when using Traefik in this setup. Because when you shut down the wrong server, you could still run into a problem and your website might not respond. And the reason behind this is that K3s runs the load balancing instance of Traefik on all 3 servers, but there is still only one replica of the main Traefik pod deployed. You can see in my example this is running on server 3, so that's why I could easily shut down server 1 without any downtime. But of course, this is not what we want. We want to take down server 3 as well if we need. That's why I simply raised the number of the Traefik replicas in the deployment. You can just edit it, change it, and then save the file. So this will update the deployment of Traefik, and now you can see it's running 2 instances of this main pod. So one on server 3 and another one on server 2. So now we can lose any of the servers and our deployment should still work. The users or the application itself doesn't even know that there was something going wrong. And this is freaking awesome. If you can deploy high available clusters on your self-hosted services with 0 downtime in a home lab. Remember, we are not in a data center, so even when the server room already looks a bit like it, but it's still just a simple Proxmox server in my home network. I hope you are as excited as I am about this whole stuff, and I probably will start migrating over my containers from my single Docker VM to the Kubernetes cluster, because I now feel much more comfortable about this technology and I understand how it really works. And I would say I can now manage and maintain this at home. But we will see. As you can imagine, there will be many more videos about Kubernetes at home on this channel in the future, because we haven't covered SSL certificates with Cert Manager, or we haven't covered storage yet. I have so many ideas how we could expand on this video and do more exciting topics in the future. But for now, that should be all. I hope you enjoyed it, and as always, thanks everybody for watching, and take care of yourself. I will see you in the next one. Bye bye.